Okay, for the third video for 1.3, we're going to talk about line of fit. So that is modeling, or the model of data points showing the approximate linear relationship. So it's getting a linear equation that approximately fits that those data points based on the points you chose to find them with. So finding a line of fit, you create a scatter plot first off. So you plot all the points that you're given and you determine, does it look like a line? If it does, it has a linear relationship. If points are all over the place and you don't see where you could actually draw a line fitting most of those points, then it doesn't have a linear relationship. But you want to draw a line that closely appears to follow the trend given. So let's just say I have, here's my graph, okay? And let's just say I have points kind of like, okay, that's kind of linear. I mean, it's got points, it's obviously got some outliers there. But what you would do is you would take a ruler or something and you would try to draw a line of best fit that would have the same amount of points. Oh, see, I missed a little bit. It should have been maybe a little steeper. Same amount of points on each side of the line, okay? Then you would choose 2 points on your line. That's step 3. And they don't have to be original data points. But then you write an equation that passes through those 2 points. And then that's your equation to model the data. So if we want to find our line of fit for number 5, now, because it's hard for me to graph on this iPad, I went ahead and showed the points here. All right, so if I do a line of fit, let me use a ruler here. It's not going to be perfect, especially because I'm doing this on an iPad, but I'm just going to draw a line. Oops, that didn't draw a line. Hold on. Whoa, and it was really thick. All right, so that ended up being my line. Hey, I covered up a bunch of points. But I need to find 2 points on there. And I like to find ones that look like they go exactly through a number. So like here, I could say, well, let's see. I could say this is 3. Whoa, that was crazy. And 2.4. Sorry, I don't know why my writing got so big all of a sudden. And then here's a point that looks exactly, and it's on 16.6. Okay, so I'm going to use those points here. Maybe if I zoom out, they won't be so big. Oh, hey, that looks a lot better. All right, so for my slope, if I say this is x1, y1, this is x2, y2, I have 6, oh my goodness, I wrote those points. Oh no, I wrote them right. I'm sorry, I thought I wrote them wrong. 2.4 over 16 minus 3. Okay, so on the top, you're going to end up with 3.6. On the bottom, you end up with 13. Let's go ahead and just get this as our slope. So 3.6 divided by 13, and I'm going to approximate. So, because remember, this is all approximation because we drew the line ourselves. It's not exact. So let's go with, it's 0.2, rounds to 8. So, because it's 0.2769, blah, 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 it keeps going. So I'm going to say this is my slope. And then let's find the rest of our equation. So y minus y1 is going to equal the slope times x minus x1. Okay, oops, let me move this a little bit. We are going to solve for y by distributing that 0.28. So negative 3 times 0.28 is negative 0.84. And then I need to add 2.4 to each side. So I get y equals, that's just a 0.28x plus 1.56. All right. So this just said, does it show a linear relationship? Well, because I could draw that line and it was pretty well between the points, I would say, yes, it does. And if so, write the equation, and our equation ended up being y equals a 0.28x plus 1.56. And then use it to estimate the total cost of a smoothie using 8 ounces of fruit. And the ounces is the x value. So for x, I'm going to plug in 0.8. So this is all part of our answer right here. But I'm going to now take the equation and plug in 8 for x. And I'm going to type all of that in my calculator. And I get that it equals, and this is a cost, so it's going to be dollars, 3.80. Okay, because cents always has 100th place. All right, and that is an approximation because we drew that line. And let's do the same thing for number 6. So we need to create a scatter plot for those points. All right, so you see my points. Now remember, you do need to draw these out on a piece of paper, or do it this way, I don't care. But then you need to draw the line of best fit. Let me see if I can make this much smaller. Oh, I guess not. Okay. Oh, there we go, thickness. So let me make it as small as I can. I'm going to draw this one red. Okay, so the first thing you have to look at is, does that look like a linear relationship? Yeah, it looks like it could form a straight line. So I'm going to try to have the same amount of lines on each side. Okay, that totally missed, but let's see if I can do it just a little better. It's really hard on top of an iPad. Then it's the other way. I overcompensated there. All right, let's try it one more time. All right, I'm just calling that good whether it is or not. So, all right. So I'm going to zoom in here a little bit, and I need to find 2 points that I could say are kind of exact there. And it's going to be hard. Okay, ooh, this one's good right there. That's 40 and then 170. And let's see. We can go a little smaller. This one right here is 30 and then 146. Okay. So there's x1, y1, and x2, y2. So let's go ahead and find our slope. So I have 170 minus 146 over 40 minus 30. So I end up with 24 over 10, and that's 2.4. All right, let's go ahead and find our y-intercept by plugging this into the point slope form. So it's y, minus our y1, and we're going to say this is x1, y1. So 146 equals our slope times x minus x1. Okay, distribute that 2.4. We get y minus 146 equals 2.4x minus 72. And we're going to add the 146 to both sides. So we get y equals 2.4x plus 74. All right, so over here it says, does it show a linear relationship? Well, we already said yes, because that's why we went ahead and drew our line, because it worked. Write your equation. So y equals 2.4x plus 74. Oops. Okay. And then it says use it to find or to estimate the height of a person whose femur is 35 centimeters long. So that's, again, x is the femur length. So for x, I'm going to plug in 35 plus 74. And then I just type all that in my calculator. And I get that y is 158, and our units are going to be centimeters because that's what the femur length was. So the height of a person is 158 centimeters, estimating if their femur was 35 centimeters long. Okay, so now that we've done these two problems, I want you to go to the practice and do problems 13, 14, 15, and 16, and then move on to the last video.